All right, welcome back to another episode of our classes. Today we'll be tackling the knapsack problem using the dynamic programming. So this classic optimization problem has real-world application like budgeting, resource allocation, and more. So stick around as we break it down to the advantages, the disadvantages, pseudocode, step-by-step process, and the practical implementation. So we'll begin first, as always, with the definition of it. So, by definition, the knapsack problem involves selecting a subset of items with given weight and values to maximize total value without exceeding a specified weight capacity. Using dynamic programming, we effectively solve the problem by building a table to store immediate results. So basically, we have so let's understand this definition by a simple example, an interesting example. So imagine you have a backpack and a bunch of toys. Each toy has a size and a fun level, but your backpack can only carry a certain amount of toys because it has limited space, right? So you want to pick up the toys that have the most fun without making the backpack too heavy, right? That's the basic concept of it. So to do this, first you check all the toys one by one. For each toy, you decide, should I put this toy in the backpack or should I leave it? Then you write down the best choices for each toy and the backpack size so you don't have to think about it again later on. So that's basically the basis of this knapsack problem algorithm. So now let's look at the step-by-step process of doing this. So this includes basically four steps. The first is initialize a 2D table where rows represent the items and the column represents the weight from 0 to W capacity. So the step 2 is for each item, decide whether to include it in the knapsack or exclude it based on the maximizing value. Then you have the step 3, fill the table by considering the value of including or excluding each value. Then the fourth and last step is the value of the bottom right cell of table will be the maximum value that can be carried in the knapsack. So I think all the problems or all the confusions will be resolved in the pseudocode. So till then, let's just take a look at the advantages. First, it offers the efficient solutions just because the dynamic programming approaches to solve the problem in O into N into W, I think, time where the N stands for the number of items and W stands for the capacity of knapsack. Then you had the exact optimization, which is like that this approach guarantees an optimal solution, ensuring that the maximum value within will lie within the weight limit. So it gives you the exact optimization. Then let's just take a look at the disadvantages of using this algorithm. Disadvantages are pretty simple. Memory uses the dynamic programming approaches. The first advantage is second disadvantages. So it basically takes O into N into W space to store the table, which makes it which can become significant for larger inputs. Then you cannot handle the fractional items. The basic dynamic programming approaches only work for I think in the knapsack problems where the items are either taken or left. It's not suited for the fractional version. Basically, in simple words, it's not suited for the fractional versions. So now discuss the advantages, disadvantages. Let's just look at the pseudocode and then we'll move on to the coding screen. So here you go with the pseudocode. You can just take a quick look at the pseudocode or pause the video and can just write it down if you want to. I'll highly suggest if you can possibly, then that's just great. If you can screenshot it, then that's also pretty much good enough. But make sure when you're sitting down coding, when you're sitting down practicing, make sure you have a pseudocode in front of you of the thing that you're coding. All right, so we are on to our coding screen right now. So let's just do that real quick. Create a function, calling it the knapsack. Found the parameters. W weight values and N. Once we're done with that, we'll initialize a 2D array to store the maximum value for each capacity. All right. So range n plus 1. That's it. Once we're done with that, we'll basically build the table in bottom-up manner. So how do we do that? By two for loops and an if, as we have seen in the pseudocode. Like if basically I equals to 0 and w is the exact same thing. Value. Then the else part would be okay. So simply we just return the DP, and that's it. We're done. So let's just test the algorithm.
Never let you go. Never let me hide. Don't you give up now. Never give up now.
That's basically the weight, the length of the weights. That's where we'll have the knapsack in front of us. Let's give it to this. All right. We had certain stuff missing up here. We're just gonna cover that real quick. And once I guess it's basically done. And you can see we have the output as 12 as expected. So basically the knapsack is used for mostly resource allocation, investments and cargo loading, or maybe also selecting ads, I think. So this was all for today. So if you found this tutorial anyways helpful, then hit the like button. If you found this unhelpful, then put on a dislike and subscribe for more tutorials like this. And we'll have every single day tutorials. Maybe we'll miss some days, but mostly it's every single day. So 20 to 25 days a month. So just subscribe to our channel and stay tuned with our class.